Okay, everybody, welcome back. This week we're going to go over volume. Okay, so volume is a measure of how much something holds, okay, or how much space something takes up. You can see here the formulas for volume are a bit simpler than those for surface area. The key thing with volume is, if you'll notice, all three of these, well, sorry, not all three, these first two, they have two things in common. Capital B and then the H. Okay, so capital B is the same as up here in surface area. It's the area of the base. Okay, area of the base. And then you have to remember the base of your shape is how it's named. So like a triangular prism is going to have a base that is a triangle. Okay, no other side on a triangular prism can be its base besides the triangles. Okay, for a cylinder, the bases are the circles. For a rectangular prism, the bases would be a rectangle. For the pyramid or the cone, it's that flat side, that either the square or rectangle on the bottom or the circle, it's a cone, just not the slanted sides, it's that flat side. So that's for pyramid or cone. So big B is area of the base. And the formula that you use to calculate the area of the base is going to change based on what the shape of your base is. So for example, if you have a triangular prism, well, you have to know the formula for the area of a triangle. So when you have that, you have to go back to your regular area formulas and you see, oh, okay, triangle. And you only want to concentrate on the triangle at that point. Don't look at any other part of the prism. Just look at the triangle and use that formula. Okay, now the next part that we have is the height of the prism. So let me go on ahead. I'll take my triangular prism example here. Okay, so we have our triangular prism. Again, the base are these triangles on the ends. So if I was trying to find the volume of a triangular prism, I would find the area of this triangle. They would tell me the base, and they would tell me the height of the triangle. Okay, find that area. And then now, in order to find the volume of the prism, I would look, okay, how far apart are these two triangles? Well, that's going to be this distance here. It's the same here. It's the same along this backside too. Okay, but just the distance between the two bases, that is the height of your prism. Okay, so that's where the H would come in from. That's the height, okay, of the prism or of the pyramid, or cone. So for a pyramid, okay, let's say it's a rectangular pyramid. Okay. So this is our pyramid, right? Our height is going to be from the center of the base up to the top. Okay, so that's the height on a pyramid. Okay, last week we talked about slant height, but that's for if you're trying to find the surface area. For volume, we just need that height, and we're going to give that to you. So again, for prisms, cylinders, pyramids, cones, okay, it's area of the base, big B, and then you need the height, H. So for a prism or cylinder, you just take the area of the base and you multiply by the height. For a pyramid or a cone, you do area of the base, multiply by the height, but then we only want 1/3 of it. So you can multiply that by 1/3, or you could divide by 3. It's the same thing. So let's go do a couple of these really quick. Go to our next page. So first thing here, we have a rectangular prism. Okay, on a rectangular prism, it does not matter which side you use as the base. Just choose one and go with it. You just have to remember the height is the distance between the two faces that are the same. So I'm going to use this smaller rectangle here as my base. Okay, and its matching one is over here on the other side. So I'm going to draw a line between two corners of the bases, and now I know that this 12 is my height of my prism. So now for big B, that's the area of the base. How do I find the area of this rectangle? It's the area of the 5 by 4 rectangle. Okay, guys, how do you find the area of a rectangle? It's base times height. And again, don't let this H right here get you confused. I'm only talking about the rectangle right now. When I'm talking about big B, this is all I see. I don't see anything else. So for big B, it's going to be 5 times 4. Okay? So it's 20. So the area of the base is 20. And now, the volume, it's a prism. It's area of the base times the height. Okay? So it's just going to be 20, because that's what we found was the area of the base. And now our height, like we said, the distance between the two bases is 12. So we do 20 times 12, and we get 240 centimeters, and it's cubed, okay? Guys, it's a 3D shape, and we're finding out how big the whole thing is, so that's why it's cubed. Volume cubed. Alright, next thing you have here is a triangular prism. Okay, it's a triangular prism, so what shape does our base have to be? A triangle. So we can see here there's a triangle up here, and the matching one down here. Okay, guys, the dashed lines are showing you where the edges of the figure are. Okay, so this guy, he's kind of looks like a block of cheese. Alright, that's how it looks. And then you have the dashed line back here, that's showing you like the back side of it. Okay, so showing you like how it's standing tall. Okay. Don't know why the eraser wasn't cooperating there. Alright, so there's our triangular prism. Okay, now from this, I need to first figure out the area of this triangle. Remember, the area of a triangle is going to be 1/2 base times height. And again, right now, I'm only concentrating on the base, the triangle. Okay, I'm using this one on the bottom because they've given me all the measurements I need on the bottom here. Okay, I could use the top one. It's going to be the same thing. So what I need is the base and the height of this triangle. Remember, your base and your height are at a right angle to each other. So I have 1/2 times, and what is the base of my triangle? 8. What is the height of the triangle? 2. So 1/2 times 8 times 2. And you will get 8. So the area of this triangle down here and up there is 8. Now the height of my prism, okay, this is of the prism. This is the distance between the two bases. So from one triangle down to the other triangle, if I draw a straight line between them, I can see the height is 7. And now, again, it's a prism, so the volume formula is area of the base times the height. So what was my area of the base? 8. What is my height? 7. So 8 times 7, 56 kilometers cubed. Just remember, when you're doing on the quiz, don't put in the units, just put the answer in there. Okay, next thing we have here. This is a pyramid. So let's hop back really quick. Go to our formula chart here. For a pyramid, the volume formula is 1/3 big B times H. So 1/3 times the area of the base times the height. So volume is 1/3 area of the base times the height. Okay, area of the base. Remember, the base of your pyramid, it's either a rectangle, a square, okay? Rectangle or square here, so we got that there. It's a rectangle, so it's just base times height. And again, this is the base and the height of the rectangle. Base and height of the rectangle. We have 6 and 5. So the area of the base, 6 times 5 is 30. Now I'm going to look at the whole pyramid itself. I know the area of the base. Now the height of my pyramid is this right here. There's the base of it. This is the height. They're making that right angle. It's 7 feet. So h is 7. And now I will plug into the formula. 1/3 times, and the area of the base is 30, and then the height is 7. So what I do in order to avoid, because I know most of us are probably doing this on our phone, in order to avoid a lot of icky decimals from this 1/3, I just do 30 times 7, and I press enter. And I know that multiplying something by 1/3 is the same thing as dividing by 3, so I just do divide by 3. Okay, and so I get 70. Another way you can enter this into the calculator, the calculators will do what you think they're going to do. You just do 1 divided by 3 times 30 times 7. You can just type it in like that, and then you'll get your answer. And again, it's feet cubed, because volume is 3 dimensions. Okay, a cylinder. Alright, for a cylinder, volume is area of the base times the height. Again, we got to find the area of the base, and since it's a cylinder, our base is a circle. So for the area of a circle, it's pi r squared. Now look here, what have they given us? They've given us this line that goes all the way across. So 6 is our diameter. Our radius, you have to take the diameter and you divide it by 2. So it's 3. So we're going to do pi times, and then our radius, so it's 3 squared. Now be careful when you're entering this into the calculator, guys. You want to make sure that you are using the actual value of pi in the calculator. Alright, so what I'm going to actually do right now is I'm just going to multiply this 3 squared here, and I get 9, and I put pi on the end. And I'm going to actually leave the area of the base like this until I get to my final step, so that it'll be even more accurate when I plug in. So now volume is area of the base, so 9 pi, and then times the height. The distance between our two circles, is 10. And now I'm just going to type this all into the calculator. 9 times pi times 10. And so I get 282.74, so 282.7 yards cubed. So there we go. So that's a cylinder. Alright, next thing we have here is a cone. Alright, a cone is like a pyramid, so volume is 1/3 area of the base times the height. And the reason for this 1/3 here on pyramids and cones is, like, if you actually take a cone, you could fit 3 cones inside a cylinder that has the same size base here. So that's where that 1/3 comes from. And if you want to see it, there's like some videos on YouTube where people actually demonstrate that they take a cylinder and then they put stuff, like they fill it up with like water or sand or something like that, and then they pour it into cones, and you have to fill out 3 cones with the same size circle to make up 1 cylinder. Alright, but that's just kind of where the formula comes from, if you're interested. So volume, 1/3 area of the base times the height. Okay, area of the base. Our base is a circle. So the area of a circle is pi r squared. The radius goes halfway across. They already marked it for us, so our radius is 12. So pi times 12 squared. So that's 144 pi. Okay, because 12 squared is 144. Now I'm just going to plug in here. Volume is 1/3. Okay, area of the base, it's 144 pi times, and now my height of my cone is right here. And just how tall it is from that base up to the point. It's 24. So just plug this into the calculator. Again, I do 1 divided by 3 times 144 times pi symbol times 24. Okay, so 1 divided by 3 times 144 times pi times 24. Press enter, and you get 3,619.11. So again, that 1 is just going to leave this first one the same. So 3,619.1. And that would be meters cubed. Okay, next one. A sphere. Okay, a sphere is a little bit different. So let's go back to our formula chart. For a sphere, the volume formula is 4/3 pi r cubed. Okay, be careful there. It's pi r cubed because volume is in 3 dimensions. So 4/3 times pi r cubed. So volume of a sphere, it's 4/3 pi r cubed. Alright, remember r cubed is r times r times r. You multiply whatever the radius, you multiply it 3 times. Okay, here, our radius, we have to take 23 and we divide it by 2 because they've given us the diameter. So 23 divided by 2, it's going to be 11.5. So we just plug in here. Volume equals 4/3 times pi times 11.5. And make sure you put that 11.5 in parentheses and then cube it. Okay, and then now I'm telling you exactly what I'm typing in the calculator on my phone. So I do 4 divided by 3 times, and then I do pi, and then times, and I put parentheses, and I do 11.5 close parentheses, and then I'm going to press that XY button on mine to get the power, and then 3, and then I close my parentheses, and then equal, and I get 6,370.62. Okay, I'm only looking at the second decimal. I'm not rounding anything else. Like it's actually 626. But in order to round to the tenths, which is what we want you to do, you just look at the second one here. So it's 6,370.6 because the 2 doesn't make it go up. And that would be inches cubed. Okay, so that's basic volume. Now we're going to get into things that are a little bit more complicated. First, just a couple of things. This one, it says, find the volume of each figure, round your answers to the nearest tenth if necessary. Leave your answers in terms of pi for answers that contain pi. So I have 2 things here. I just wanted to give you one to where, like, if they described a pyramid to you, you'd be able to do it. So it says a rectangular pyramid with a height of 12. Okay, so h is 12. And then it's measuring 8 inches and 9 inches along the base. And it's a rectangular pyramid, so our base is a rectangle. So it's an 8 by 9 rectangle. So the area of the base would be 8 times 9. Okay, 8 times 9, 72. And now we just plug into the formula. It's a pyramid, so it's 1/3 area of the base times the height. So 1/3 times 72 times 12. So again, 1 divided by 3 times 72 times 12. It's 288. inches cubed. Okay, now here, a hemisphere. As a hemisphere is half of a sphere. Is the top or the bottom half is cut off, just half of it. Like the northern hemisphere, southern hemisphere, eastern, western, all that. Half a sphere. It says a radius of 4 centimeters. So volume, it's 4/3 pi r cubed, but we only want half of it, so you can either multiply by 1/2 or you can divide by 2, whatever you like. I'm just going to do divide by 2. And you have to do the whole top part first and then divide by 2. So basically get the volume of a sphere, press enter, and then just do divide by 2. So we will do 4/3 times pi times, and then our radius is 4. We cube that and divide that by 2. So 4 divided by 3 times pi times 4 to the power of 3, close parentheses, press enter. Now I keep all those decimals. I don't do anything, I don't shorten anything here, and I just do divide by 2, press enter again, and so I get 134.04. So it's going to be 134 centimeters cubed. Okay. Now this one here. This is working backwards, alright? And we're really going to have you do this with just cylinders, but you should be able to solve any of these volume formulas backwards. A cylinder has a volume of 44 pi centimeters cubed. Okay, so V is 44 pi. The cylinder has a radius of 3, so R is 3. What is the height of the cylinder? Okay, so right away I just go and say, alright, a cylinder, it's area of the base times the height. But since it's a cylinder, I know my formula for the area of the base is going to be pi r squared. So V is going to be pi r squared h. All I'm doing is substituting in for area of a circle here because it's a cylinder. So now I will plug in what I know. My volume is 44 pi. My radius is 3, so it's 3 squared. And then I don't know my height, so it's still h. So now what I do, I look and I see, okay, pi and pi, they can cancel. So I have 44 is equal to, and I'm going to actually evaluate 3 squared. 3 squared is 3 times 3, so it's 9. I have h. So all I do to get h alone, just divide by 9. So do 44 divide by 9. So you get 4.8. It's like 8 repeating, right? So look at the second one here. The 8 is definitely going to make this other 8 round up. So the height would be 4.9 centimeters. Alright, there you go. So just on these working backwards ones, just, substitute everything in. Whenever you're doing the area of the base, just make sure that you are using the appropriate area formula for whatever shape base it is, and then just solve for the thing you need. Okay. Now, this next section that we have here, this is about dimensional change. Okay? It's going to talk about changes in perimeter, area, and volume based on a scale factor. So let me go on ahead and add in another page really quick. Okay. So dimensional change. Alright, they're going to give you a scale factor, and then you might be asked by, how much is the perimeter of something going to change, how much is the area going to change, how much is the volume going to change. Okay, perimeter all you do is just multiply by the scale factor. Okay? Perimeter just changes with however much the scale factor is. So like for example, I have a square right here and each side is 2. Okay? So my perimeter, what would be 2 plus 2 plus 2 plus 2 would be 8, right? Now let's say the scale factor is going to be 5. Okay, so that means that the scale factor is going to be 5. The dimensions of each side of the square are going to change by 5 times. So originally there were 2. Well, each side is going to get multiplied by 5. So what's 2 times 5? 10. So now each one's going to be 10. And so now think about it. The perimeter, I have 4 sides that are each 10. The perimeter is going to be 40. Well, look, how do you go from a perimeter of 8 up to a perimeter of 40? You multiply it by what? 5. 8 times 5 is 40. 8 was your original perimeter. 5 is the scale factor. And 40 is your new perimeter. So perimeter, you just multiply by the scale factor. Area. And this is also surface area. Okay. Area, you multiply by the square of the scale factor. Okay, because think about it, area, it's a 2D measurement. So that means the little exponent, you know, like inches for area, it's inches squared. So you take your scale factor, whatever it is, and you square it. So let's say here, go back to our little square. It's a 2 by 2 square. So the area is 2 times 2, so it's 4, right? Again, let's say our scale factor is 5. Well, again, look, that means that the sides are going to be 5 times as big. So 2 times 5 is 10. Okay, so now it's a 10 by 10 square. Well, what's the area? 10 times 10? It's 100. So think about it. If my original area is 4, okay, that's the original. Now I have to multiply my, like 4 times what gives me 100? 4 times 25, right? Well, 25 is 5 squared. That scale factor, if you square it, multiply it by the original, that's going to give you the new area. Okay, now volume. Okay. Volume, you multiply by the cube of the scale factor. So what that means is you take your scale factor and you raise it up to the power of 3. Okay? That's what that means. Raise it to the power of 3. So let's say we have a little rectangular prism here. Okay, please forgive my artwork. Let's try to do that a little better. Okay, that's a little better. Let's say that it's 2 by 2 by 2, okay? So it's 2 by 2 by 2, and I'm highlighting the sides I'm referring to. The volume of this little cube would be area of the base, so 2 by 2, times the height, is 2. So 2 times 2 times 2 is 8. Now let's say my scale factor again is 5. Alright? This volume, this cube, my dimensions are going to be 5 times as big because the scale factor is changing each individual dimension. So for volume, the length, width, height. Okay? So now my cube instead of being 2 by 2 by 2, well, 2 times 5 is 10. 2 times 5 is 10. 2 times 5 is 10. So all of my sides got multiplied by 5. So now my volume be 10 by 10 by 10, which is 1,000. Well, how do you go from 8 to 1,000? So 8, that's your original volume. 1,000 is our new volume. If you do 1,000 divided by 8, you get 125. So you'd have to do 8 times 125 to get 1,000. Well, where do I get this 125? 125 is 5 cubed. That's your scale factor cubed. Okay? And the reason why volume changes by the scale factor cubed is because you are increasing the measurements in 3 dimensions. So you're doing times 5 this way, times 5 this way, times 5 this way. So 5 times 5 times 5, that's 125. Okay? So this is kind of the concept that we've got going on for dimensional change. Okay? Perimeter. Let me find it here. Okay? Perimeter is just going to change by whatever the scale factor is. So you just multiply by that scale factor. Area and surface area, it's going to change by the square of the scale factor. So you take your original, you take your scale factor, and you square that. You multiply the two together, you get the new one. Volume is going to change by the cube of the scale factor. So again, you take your original, you take the scale factor, and you cube it, and then you multiply, you get the new one. Okay, so let's look at these ones here. It says, a 5 foot by 5 foot flower box can have 100 flowers in it to ensure optimal growth. How many flowers can be grown in a box that has dimensions 3 times this size? Okay, so all we have to do, just let's conceptualize this here. We have our original one, 5 by 5. So every 25 square feet can have 100 flowers. Okay? 100 flowers. Now, let's say that our box has dimensions 3 times that size. Well, instead of the box being 5 by 5, it's now going to be 15 by 15. Okay? So think about this. How many 5s can fit in 15? 3 of them. So it's going to be 3 times as big horizontally. And then we've also got 15 going this way. This is going to be 3 times as big vertically. Each of these little boxes is one of these guys right there. So if each of these can hold 100 flowers, how much can the whole big box hold? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. So this box can hold 900 flowers. So look at that. 100 times, and now we're dealing with area, so it would be the scale factor squared. So 3 squared, that's 100 times 9, which is 900. So this first thing here with the pictures, that's the conceptual. I'm trying to show you how you could figure this out. Over here, with just the numbers, I said, okay, I take the original, I multiply it by the scale factor squared. That's going to give me my new one. So, and I did scale factor squared because I'm dealing with area. Okay, so I'm going to go down here to problem number 12 and let's deal with area again. It says the area of a hexagon is 35 centimeters squared. What is the area of a, sorry, this should be hexagon. Okay, what is the area of a hexagon if the sides are 4 times as big? Alright, so take your original. My scale factor is 4. And we're dealing with area. Okay, so do area. So 4, you have to square it because it's area. So original times the scale factor squared, that's going to give us the new one. So 35 times 4 squared. 560. So the new hexagon would be 560 centimeters squared. Okay. And now we're going to go here to volume. Okay, a rectangular, I'm going to number 11. A rectangular prism's dimensions are reduced to 1/5 their original amount. How many times smaller is the surface area of the prism? How many times smaller is the volume? Okay, on this one, all they're asking you to do is what would you multiply the surface area by? What would you multiply the volume by? So for area, I would do 1/5 and I would square it. Okay, so that's 1/5 times 1/5. So that's 1/25. So the area would be 1/25 the original. And now the volume. Okay, since we're dealing with volume, we would cube it. So do 1/5 times 1/5 times 1/5. So 1 times 1 times 1 is 1. And 5 times 5 times 5 is 125. So the volume would be 1/125th. So these would be your answers there. Alright. This one here, it says a triangular prism has a volume of 62 centimeters cubed. If its dimensions are made to be 7 times the original size, what will the new volume be? Alright, take your original 62 times, and then we have our scale factor is 7, but we're dealing with volume, so I have to cube that. So we just do 62 times 7 cubed, and we get 21,266. So it's really just, determining, are we dealing with perimeter, area, or volume? Okay, and then our last one here, for dimensional change, it says the similarity ratio of two solids is 3 to 7. Okay, so automatically write that as a fraction. What is the ratio of their areas, of their volumes? Okay, so for area, you would just do the original and you would square it. So that's going to be the top squared over the bottom squared. Okay, and you just leave it as is. So 3 squared is 9, 7 squared is 49. Okay, so it'd be 9 to 49 for area. And then for volume, well, we're dealing with the cube of it, so we have the original. So it's 3 cubed over 7 cubed. So 3 times 3 times 3 is 27. 7 times 7 times 7 is 343. So for volume, we'd have 27 to 343. So all you're doing is taking the scale factor and you're either squaring both sides of it for area or you are cubing both sides of it for volume. Okay, next thing we have is for these special kind of figures here. The first two, these are called oblique. All right, this is a cylinder, and it's just kind of like someone took the top side of it and like pushed it over a little bit. This one over here, this is a cone. Okay, I know it doesn't really look too much like a cone from this picture, but this is like a cone, and it's like if someone took the point over here and just like dragged it to the side. The formulas for these, even though they're like tilted, they're the same. So for a cylinder, it's area of the base times the height. For a cone, it's still 1/3 area of the base times the height. The height they're showing you in this picture right here. Okay, so for a cylinder, the area of the base is pi r squared because our base is a circle. So pi times, and then here we have to look, our height is 3.4, the radius is 2.1, so 2.1 squared. Okay, so I'm going to do just 2.1 squared, and I get 4.41 pi. Okay, 4.41 pi. And so now what I need to do is plug in with the height. So volume 4.41 pi times, and now the height is 3.4. Okay, 3.4. So just multiply these, and this one says round to the nearest tenth. So 4.41 times pi times 3.4, and so we get 47.1 centimeters cubed. Okay, next one here. So again, it's a cone, so my area of the base is pi r squared. In this case, my radius, I have to do 13 divided by 2 because 13 is the diameter. So 13 divided by 2, you get 6.5. So you have pi times 6.5 squared. So we get 42.25 pi. And so now volume is 1/3 times 42.25 pi times, and then the height of my cone, you don't want to like think about the slant here. They're just going to tell you the height of it. It's 19. So again, 1 divided by 3 times 42.25 times pi times 19, and so we get 840.6, 840.6 inches cubed. Okay, so there's that one. So again, it's just, they're the oblique cylinders and the oblique cones, they're the same formula as a regular cylinder, as a regular cone. All right, last piece. Thank you for hanging in there with me. I know it's been a long time, okay? So our last ones here, these are composite figures. So all you have to do is basically break the figure up into the two pieces that you see and then add them together. All right, so first thing here, we have two rectangular prisms together. All right, so I'm going to do the blue one. Blue, and then we have a red one. Now you're going to have to use the measurements given so that you can figure out the different dimensions here. Alright, so first thing, I can see this prism, this 2, it applies up here, and then it's also right here, so this is 2. And that means that this one up here is also 2. Okay? So the width of this prism is going to be 2. Now, as far as this measurement right here, because I'm concentrating on the blue prism first, the tall upright one, you can see the height of it is 10. So I'm going to call that my height. And then this top rectangle and the bottom rectangle, those will be my bases. Okay, so let me actually call this my base. And the base, it's 2, and then now I need to figure out this piece right here. Okay, how am I going to figure that out? Well, I know that right here, from this corner to this corner, that's the same measurement, so it goes straight down. So from here to here, I need to know that distance. I can see across the whole bottom is 12. So I have to look at this other prism right here. See, from this point to this point, it's 8. So from here to here, that's 8. And the whole thing is 12. So what's 12 minus 8? Well, it's going to be 4. So my rectangle up here, it's a 2 by 4 rectangle. So for the first one, volume, it's area of the base times the height. Area of the base, it's 2 by 4, so it's 8. The height is 10. So just plug in 8 times 10, so it's 80. So the volume of this blue upright one is 80. Now I'm going to go to the red one. Okay, this one's a little bit easier because I got all of my measurements. So volume is area of the base times the height. I'm going to use this rectangle as my base. Okay, it's 2 by 3. So the area of the base, 2 times 3, 6. And then my height is going to be from this rectangle over to this one right here. Okay, so my height is going to be 8. So I'll just plug in. Area of the base is 6 times the height, which is 8. So my volume is 48. And so now my total, okay, total is going to be 80 plus 48. So 128. And that would be inches cubed. Okay, so just on the composite figures, you find the volume of the two separately and then you add them. Okay, now over here, you can see this looks like an upside down ice cream cone. We've got a cone on top and a hemisphere on the bottom. So I'm going to do the volume of the cone. It's 1/3 area of the base times the height. Both figures share the same base, and that's what you will notice for composite figures. They both have this same circle that is common to them. So for the cone, the area of the base is pi r squared because it's a circle. So pi, and then the radius of that circle is 6. So pi times 6 squared, so 36 pi. And then now the height of my cone, well, how tall is your cone? It's 15. So the volume of the cone, it's 1/3 times 36 pi times 15. Okay, if I wanted to leave this in terms of pi, I just type in everything except for pi into the calculator. So 1 divided by 3 times 36 times 15. So that'd be 180 pi, but they want me to round it to the nearest tenth. So just press enter and do times pi. Get 565.5. So that's the cone. Okay, now I have to do the hemisphere. Volume of the hemisphere. So a regular sphere is 4/3 pi r cubed but I only want half the sphere, so I'm going to take that whole thing and divide it by 2. So again, calculate the whole top and then just do divide by 2. So I'll do 4/3 times pi, and then my radius, it's the same as the cone, it's 6, so 6 cubed. Divide by 2. So how I'm saying it is exactly how I'm typing it in. 4 divided by 3 times pi times 6 to the power of 3. I press enter, and then I don't do anything to the number. I just press the divide button and then by 2 and press enter again, and I get 452, and it's 0.38 on the calculator, so it's going to be 452.4, and that would be inches cubed. Okay, so there it is for volume, and I realized, I think, let me go back and check here. I think on our other volume problem here, oh yes, with our hemisphere, it says leave your answer in terms of pi. I totally typed in pi in the calculator. So let me fix this really quick. Okay, but in general, this is volume, okay? So on this one, this is what I'm going to do. I'm just going to do 4 divided by 3 times 4 to the power of 3. Press enter, and then divide that by 2. So it's 42.7 pi, okay, which is 134. So if they tell you to leave your answer in terms of pi, just don't type in pi when you do all this and just put it on at the end. If they tell you to round to the nearest tenth, then just type everything in and round there. So that's it for volume. So I know it's a long video, so I hope that it was helpful to you guys, and I look forward to seeing you next week.